guessing. There's no reason to guess, especially when you're a math student. You're a math student. You don't guess. Love it when they use the power tool in class. Last year, right there, final leaf blower, right in the middle of it.
At least how long is it going to take for that building to finish?
Oh, I think it's either spring of 23 or fall. So square root domain. So hopefully you know on the X and Y axis, real numbers only. There's no imaginary number. No, A plus BI, there is no I part, there's no complex numbers. So you cannot take the square root of negative numbers. Cube roots, sure. Odd roots, yeah, you can plug negative numbers into an odd root, but you can't do a square root of a negative. So you can only take the square root of non-negative numbers. Now, we don't say the word positive. We say non-negative because what's the first number that you can take the square root of? 0. 0 is the first number you can use inside of the square root. Square root of 0 is 0. So the domain goes from 0. This is inequality notation. X can be greater than, or it could equal to 0, but it has to be less than infinity. That's inequality notation. I didn't think I covered inequality notation versus interval notation, did I? Okay. So in other words, if we simplify that, we're just saying that X has to be greater than or equal to 0 for the domain. Now, on the number line, that means you would have a solid circle on the 0. And the domain would be, you would shape everything on the number line to the right, greater than or equal to that. And you draw a little arrow, and that's the number line, picture of greater than or equal to 0, everything to the right of 0. So you have the inequality, X is greater than or equal to 0. You have the number line picture, and then interval notation. Interval notation is a way to write these inequalities without the greater thans and less thans. So when you write the interval notation for this, the x's, we always go from left to right. The x's start at 0 and it equals to 0. When you have equals, you have a bracket. So it's a bracket from 0 and it goes all the way to infinity. Infinity is always parentheses. When it doesn't equal something, or when, in this case, infinity, it cannot equal something, it's a parenthesis. So that is the interval notation for this inequality notation. Not everybody is familiar with this. It just depends upon where you've been, what you've been doing, how much you can recall. But when you look at the back of the book and you're trying to figure out, okay, what's the domain? They're putting this kind of notation in the back. That's what they're putting. You said, sometimes you'll say all real numbers. For x squared, the domain was all real numbers. Well, that's not what you can put. Mathematically, what we're talking about is the x's are bigger than negative infinity, and they're less than positive infinity. They're somewhere between negative infinity and positive infinity. On a number line, you basically are shading the entire number line from left to right. That's what that means, all real numbers. Everything on the number line works. But for interval notation, it's everything from negative infinity on the left, so parentheses, negative infinity, to positive infinity to the right. And I know exactly where I left off was 1 over x. And we talked about the asymptote that happens at x equals 0. So f of x equals 1 over x. X cannot equal 0. So we would say the domain is all real numbers except x cannot equal 0. And if I ever misspell something, please let me know, because as I get older, I just start misspelling things left and right. I used to be really good. Now it's just fading away. But that's spelling. That's not mathematical. Okay. We would say this: x is greater than negative infinity, or x is less than positive infinity. So let's remind everybody what the graph looks like. We have the vertical asymptote because you can't divide by 0. So the vertical asymptote here, it's like a wall. And the graph is this on the left-hand side. And on the right-hand side, it is this. But we can plug in every single number this way and that way. I take that back. I just messed this up. I know I just messed this up. Dang it. Got ahead of myself, and that's why I paid the price. So either erase it or cross out what I just wrote. I didn't complete what I needed to complete. I left something out. I left out the 0 part. It's like there's something buzzing in my head and I can't teach it. My wife's. Okay. So over here, these x's are, and I wrote it backwards, these x's have to be less than 0 because they're the negatives, or these x's have to be greater than 0. That's what it is. That's what it is. Not even. But everything to the left of 0, everything to the right. But the word or is not mathematical. So you're going to see things that are going to change your vocabulary, because you're going to get into a class and there's going to be somebody up here that assumes you know stuff. And they're just going to start writing. And if you don't know something, you can ask, but they're going to assume you can speak a language that you may never have seen before. The way this is written, x is less than 0, or x is greater than 0. That looks like a U, and that symbol actually means union. So, okay, it's a U. U for union. But it also means or. When you're talking about sets, and that's what you have, is this domain is a set. It's a set of all real numbers except 0 is not in it. It's a set of all x's that are less than 0, the set of all numbers that are greater than 0. Union joins those two sets together. It combines all of those elements of each of those sets, combines them together and makes one set. So it joins all those together. That's what union is. It's a joint. The union of matrimony is a joining of two people together. A union in a workplace is a joining together of the workers in that workplace. Union means you're going to join them together. So you take elements of one set, elements in another set, and you join them together. If it's an upside down union, this is union. This one upside down means intersection. Union replaces the word or. Intersection replaces the word and. Union is for combining everything together, and is where do the two sets overlap each other? What values are in one set and in the other set at the same time? One of my favorite classes getting my degree was set theory. And we would do proofs, and I remember doing proofs that were 180 steps long. And it was all based on intersections and unions of different sets and all the rules that govern how sets were put together. When you study algebra above the, when you're done with calculus, if you're a math major, when you're done with calculus, you take algebra again, but you study the rules that make algebra work. You get into fields and you get into group theory, field theory, okay? What makes something a group, what makes something a field, and how all the rules join things together. I remember saying to myself, where do numbers go? I haven't seen a number like it 3 semesters. Why would I see a number again? Okay, so it's a revelation. Okay, so how do we do interval notation? Well, less than 0 is everything, parentheses, because it's coming from left to right, from negative infinity, and it's going to stop at 0, but because it does not equal 0, it's a parentheses, because you can't equal to 0. Over here, you can plug 0 into a square root. So because you can equal 0, if you can't equal the value, that's a bracket. So when you can equal, it's a bracket. When you can't, it's a parenthesis. On the right-hand side, it's everything greater than 0. So that's going to start from 0, but again, it doesn't equal it, so it's a parentheses. And it goes all the way to the right to infinity. And then what holds them together is it's a union of those two sets. This is how you would write it using interval notation. And that's everything from negative infinity to 0, but not including the 0, joined together. Union, the set of everything from 0, but not including the 0 to infinity. Okay, that's what those symbols mean. But it's not going to be inequalities in the back.
And that interval notation will commonly be done with f of x equals 1 over x.
That will commonly be done from here on out when you do anything regarding
So with any
domain, ranges, any type of inequality. They usually will ask you for write your answer using interval notation. So when we do the domain or range of a tangent curve, we basically have to do everything except pi over 2 and multiples of pi over 2. So we would write it using interval notation. What's the domain or range of sine curve? Well, domain would be, or the range would, domain would be negative infinity to infinity, but the range is -1 to 1. So that would be brackets on the negative
Yeah,
1.
I like thinking, remember this from high school.
So
My teacher explained a lot more.
okay, that may be,
I'm like trying to recall it.
that's fine. That's fine. But it's just a matter of making sure that when people see this in the back, they're looking at the back saying, all right, this is what it represents. That's all. Okay. All right. So back to the square root. The best thing about a square root, when you got to graph a square root, the picture of the radical is exactly what the picture of the square root looks like. A square root curve, it just to help you remember. That's all I'm looking for, is a way to remember. What does a square root look like? When you graph a square root, remember you can't plug in the left-hand side, but we can take the square root of 0, and if x is 0, square root 0 is also 0. So we're at the origin. Now, when you plug numbers in, if you were going to graph something one number at a time, you're just going to plot numbers. Plugging in the next nice number would be square root 1. Probably would pick 1. And square root of 1 is just 1. So if 1 goes in for x, 1 would come out for y. And you would get 1, 1. But the problem happens when people go to the next number. And they go, all right, let's plug in 2 because that's what you usually do. And if you go, all right, f of 2. 2 goes in and we get square root 2. Square root 2 is an irrational number. So that's a decimal that doesn't repeat, decimal that doesn't terminate. So there is no easy way to plot square root 2, other than the fact it's somewhere between 1 and 2. It's 1.414 approximately. But why pick numbers that don't come out nicely? You have square root 0 is 0. Square root of 1 is a 1. 0 is a perfect square. 1 is a perfect square. So 2 is not. 3 is not. The next perfect square would be 4. Square root of 4 comes out to be a nice 2. So instead of picking 2, pick 4. Square root of 4 is a nice 2. So when 4 goes in, the y value is a 2. And now you're here. Then you got to think. Square root 5 is not real nice. Square root 6 ain't nice. Square root 7 isn't nice. Square root 8 isn't nice. The next perfect square is 9. So if you were randomly choosing numbers, don't do it randomly. Do it with some thought. Okay. Perfect squares. F of 9, square root 9 gives us 3. So when 9 comes in, 3 comes out. So that would happen at 5, 6, 7, 8, 9, not the scale. And up here is 3. And you can see that this graph is slowly increasing, very slowly, but it's going to increase as x gets bigger, the y's get bigger. It's just increasing really slow. Square root x is a form of the inverse function for x squared. And we did this one. X squared looking like this. That curve, 1, we get 1, 1, 1. When you plug in 2, we get 4, 2, 4. When you plug in 3, we get 9. We get 1, 1, 2, 4, 3, 9. Over there, we get 1, 1, 4, 2 instead, 9, 3 instead. The x and y's are switched. That's what makes it an inverse function. Okay, and that's something we talk about in chapter 1. We review what inverse functions are. So, first of all, there are no y values down here. So the range, and I prefer, just for me, my picture helps me figure out what my range is going to be. The y's are above the x-axis. All of my y's have to be above and not below. So that means they're greater than or equal to 0. And putting it in that inequality notation will help me figure out what my interval notation is. I always write it like this. Number one, for me, just to help me figure it out. But number two, might help students figure it out. But the picture is where I'm getting it from. There's nothing down here. The smallest y starts here. And it's equal to that 0, so we have an equals. So the range would be bracket on the 0, and it's greater than forever. So it's going to infinity, just going to the slope. Okay. Not as fast as the x coordinates. Right. Now, when I said it looks like the radical sign, the square root and the radical sign, they have a little bit of shape in common, just a little bit of shape, and that's what I try to get across is when you're trying to graph these things and you don't get to use a calculator, it's always going to look like this shape. Now, is it always going to go to the right? No. We are in chapter 1, we are going to flip it up and down. We're going to flip it left and right. We're going to move it, stretch it. We're going to be feeling, basically transforming it all over the place. Okay. All right. So those are our algebraics. And just to give you a preview, chapter 5 is all the trick. These are our transcendental functions. Okay. Functions that cannot be formed from the linear function by using algebraic equations. We cannot rewrite it using algebraic equations. In calculus, you learn how to write this as the sum or difference as a series of algebraic expressions. So we can transform it into a series. You know what a series is. You have a Maclaurin series, you have Maclaurin polynomials, you have those kinds of things. It's the sum or difference of an infinite number of rational expressions that either converge or diverge from something. If it converges to sine x, that's a Taylor series. And there's a certain number of Taylor series that actually will substitute for sine x, because we may not be able to do something in calculus. And that's the deal. If we can't do something the way it's written in calculus, there's got to be a way to rewrite it using some other notation, maybe switching it out for another kind of representation. It's a language. In language, we substitute all the time. There's multiple ways to fix it. We can convert x's and y's for graphic in trigonometry. We can convert degrees into radians. And then we can convert x's and y's into radii and theta. We can convert it into polar. We can convert it into parametrics. Converted x's and y's into respects to time. So it's x and y change with respect to time. We now have a way to graph that. It's all related. But we will be doing a lot of this. Okay. Non-elementary, you got your absolute value and your greatest integer. And that's in chapter 1. We will be talking about these guys. Want to point out this part right here. I've already talked about it, but I want to make sure that you see it. Ways that you graph a graph. Rewrite the equation so only one of the variables is isolated. Get one variable by itself. Get y by itself or get x by itself. You will learn a parent list of equations. Y equals x squared is always going to be a parabola. Y equals x cubed is always going to look like this. Okay. Natural log is always going to look like this. Wait. Natural log. This is going to be e to the x or 10 x exponential. Logarithms don't hurt this. Make a table. If it's something you've never seen before, plug in some numbers, you make a table, you plot some points, and then you connect them with a best fitting curve. That's what they do in stats all the time. They gather data, they plot the data, and they try to find the best fitting curve for the data. Sometimes you use a calculator and it'll find some kind of quadratic or cubic or some kind of polynomial that'll fit the curve, that'll fit all the data. So they can use that equation to predict what might happen in 5 months, 8 months, a year from now. Because a scattering of plots is not going to be good enough. You want to find the best fitting graph. Plot the points into a rectangular coordinate system. Rectangular just means X's and Y's, and connect it with a smooth curve or a line. Okay. We're going to get to the homework today as well. And we're going to deal with the graphing calculator and show you with that. We'll do that with the homework. But when you do the graphing calculator, things I want to point out. On a graphing calculator, when you go to put in the equation, you cannot input this. And one of the ones that we're going to do right now is an actual homework question. Let's see which one it is. X squared plus y squared equals 16. Directions say use a graphing utility to graph a circle. And the reason why this is a circle, this is not one of the ones that we talked about in the beginning. Both X and Y are squared. Usually only one of them has been squared. Only X has been squared or only Y has been squared. That's the only thing you've seen. X has been squared or Y has been squared. That's it. This time we have both of them squared. This is where we're dealing with conic sections. When you have X is squared and Y is squared. So conic section, again, something we will actually dive into. This is just an example. This is just a taste of it to begin with. Conic sections are parabolas, hyperbolas, ellipses, circles. Okay. A conic section comes from, it's a slice of a cone, a section of a cone. Okay, solve for y. So we got to get y by itself. Use a graphing utility to graph each of the resulting equations in the same viewing window. Adjust the viewing window so that the circle appears to be circular. So I'm going to show you how to do all that. So we have to solve this for y. So to get the y by itself, we're going to subtract x squared from both sides. So on the left side, I got y squared. On the right side, I have negative, or let's just do 16 minus x squared. Solve for just y. You want y. So to solve for just y, you take the square root of both sides. When you take the square root and we are solving, not simplifying, solving. Plus minus. Whenever you're solving, it's a plus minus. So we get plus minus the square root of 16 minus x squared. So that means for this y value, we have two separate equations. We have a negative square root 16 minus x squared, and we have a positive square root 16 minus x squared.
What is the plus minus again, because it wasn't a equal square root, right?
Because, yeah, we are, whenever you solve and you take the square root of both sides, like if you had x squared equal 20 and you're solving for x, so you take the square root. We want every single possible answer that might work because it's an equation. So what can I plug in for x that would make this true? So x is equal to plus or minus, this would be 2 square root of 5. Okay. Positive 2 square root of 5 works and negative 2 square root of 5 works. They both would work. If you just had simplify, what's the square root of 20? There's no equation. It's just simplify. Then you only put the positive answer. Because it's not an equation, this is equal to just 2 square root of 5, because it's not an equation. We're not solving for a variable. All right, so graphing calculator. Always make sure, right now it's algebraic, so it doesn't matter if you're in radians or degrees, but you want to make sure that this right here, make sure it's on normal, make sure this is on function mode, not parametric, not on polar, not on sequence. You want to make sure that this is on connected. So I get mode right here. So mode pulls up this screen right here. Okay. And you want to make sure this is not connected, so it actually draws a connected graph. Sequential, okay, so that means it's going to graph one equation, then it'll graph the second equation. If you put it on simul or simultaneously, it graphs, and right here you can see y sub 1, y sub, you have 7 different equations you can graph or more. It would graph all 7 at the same time, and you wouldn't know which one's which. Okay, real numbers versus polar versus, complex versus polar numbers, and then a full screen versus horizontal, and then GT, I'm not even sure what GT. Okay, so everything looks like it's good, checks out. And I'm going to go to the y equals button. And I'm going to first punch in the positive. So I'm going to go square root. I'm going to put on my glasses. I can see the dang thing. Oh, square root, and that's 16 minus x squared. Now the x that you're going to punch in is right here. It'll give you an x if you're in rectangular coordinate mode. If you're in parametric mode, it'll put t in there for you. It'll give you a theta if you're in polar mode. It'll give you an n if you're in sequential mode, sequence mode. Right now, we're just going to hit that button and you're going to get an x. And then the square button is over here. Then you got to make sure you close the parentheses. Okay, that's one equation. Now, positive. If I graph a positive square root, a positive square root x, the graph is going to go up like this. If I put a negative in front of the square root, a negative square root x, then all of those positive answers are now going to be flipped. They're going to be negative y values, and it will graph below it like that. So it gives you 2 parts. It gives you one above the x-axis, one below the x-axis. So I hit enter, and the second equation. Now, when you hit a negative, because you got to have a negative in front of it, you can't put this one. You can't put minus. That's not a negative. This is your negative right here. If you put minus instead of a negative, it's going to have an error. You want to hit negative and then the square root. 16 minus the x squared, that's a 19. And then make sure you get in. Okay. So the directions, real quick, they don't tell us what window. It says adjust the viewing window so that the circle appears circular. So here's the window we can start off with. I'm going to use zoom. And I'm just going to tell it zoom decimal. Zoom decimal. So that would be number 4. So you can either go down 4 or you can just hit the number 4. And obviously that's not enough. So let's think for a second. One thing you'll learn if you haven't done the equation of the circles yet. The equation of a circle is going to look like this. It's going to look like x minus h perfect square plus x minus y perfect square equals the radius of the circle squared. That's the standard form for the equation of a circle. The h and the k represent the center of the circle. So since I just have x and y and there's no minus, there's no parentheses, the h and the k, h has to be a 0, k has to be a 0. The center of this circle is the origin, 0, 0. Now 16 represents the radius squared. So if 16 is equal to the square of the radius, then what's the radius of the circle actually going to be? 4. So if we look at my graph, and if I want to see, now here's where you might want to pay attention to this. When you go to window, it tells you the scale that you're using from left to right and top to bottom, bottom to top. The x minimum, this is negative 4.7. That's positive 4.7, which is, that's why we can see the part of the circle from left to right. We can see that because the radius is just 4. And that's negative 4.7, so it's big enough. But the y minimum and the y maximum, this is negative 3.1 and the radius is 4, so that's why it's not big enough. And this is 3, and that's 3.1. And up here, the radius goes all the way up to 4. It's not big enough. So what I can do is I can change, if I just scroll on down, I can change that x minimum to a negative 4 and the x maximum to a positive 4. And let's see how my graph looks like now. Now, it's not too bad as circles go. Not too bad. But when you look at this right here, it almost looks more like it. Okay. Looks more like it. So here's the key that fits it all together. Keyword fit. When you don't know what to make your X min, X max, Y min, Y max. When you go to zoom, you go, basically you go all the way down. If I keep just hitting down, it'll go all the way down to 8, 9, 10, and so on. But you know what? It scrolls. So if I scroll up, it goes to the bottom and it'll go backwards. Right there, option 0, which is option number 10, zoom fit. It'll refit the window to match up with the X min and X max that you have. So if I hit zoom fit, it's going to give me some better Y's to work with. Now, it still looks like an A. So that just gives me a better idea of what those X min and X or the window should be numbered at. How you make it a better looking circle is you go to zoom one more time. And the last thing you want to hit is number 5, zoom square. Zoom square is now going to take my window and it's going to rearrange things and square it up so I actually get the picture of the circle. So the last zoom you hit is zoom square. Now, as you can see, it looks like a Pac-Man. We got a little missing piece right here. And that's because it actually looks and it's approaching, what's happening is it's approaching such a vertical part that it doesn't want to graph that piece. But that's as close as you're going to get. Just realize that you're graphing a circle. It doesn't like to graph vertical lines. It resists graphing vertical lines when it's in rectangular mode. And it becomes almost vertical right there. Now, if I had done this, you see. No, it's still going to zoom. It's going to zoom square to here. Okay. But that's what they're asking you to do on that problem. Okay. So that's 55. The last bit of notes before we go over homework extensively was on page 79. Right here, applications. Now, throughout this course, you will learn that there are many ways to approach a problem. It's George Polya, very famous mathematician for problem solving. That whole, when am I ever going to have to use this idea? And his famous saying, because he wrote a whole book on problem solving, many books on problem solving, his famous saying is, it's better, or he actually used the tis better to solve one problem 5 different ways than to solve 5 different problems. Because when you solve one problem 5 different ways, you have your brain thinking so many different approaches. That's hard. I mean, think about how stubborn we can be. I only do it this way. I only do it that way. I don't, and from my perspective, I need to be able to teach something when somebody doesn't get it. I got to teach it a different way. You're not getting it, I got to kind of come up with another way to make it, sync. Algebraic approach, using the rules of algebra, graphic, draw a picture, use graph, numerical, construct, use a table. Those are the 3 different ways you can basically approach a problem. And we're going to be doing some word problems throughout our homeworks, and there will be just no more than 2, maybe 3 on a test. Not as many, these come, here's the word problem, do parts A, B, C, D, E, F. I'm not going to hammer you with A through F. Maybe do part A, do a B, maybe. But usually answer one part. Okay. All right. So now, this is the homework. First part. And if there's ever a formula you don't know by heart, if it doesn't come up that you know it by heart, you got to ask. Rate, what does rate equal? Distance divided by time. Rate is equal to distance over time. Why should you know that? Well, you should know that since the 2nd grade, but do you know what miles per hour represents? Miles divided by hours is equal to your speed, right? Which is a rate. Miles is a distance, hours is a time, and that equals a rate. So distance, what does distance equal? Multiply both sides by t. Rate times time. You actually know miles per hour. Yeah, I've heard of that before. What does that mean? Oh, that's how fast I'm going. Oh, you mean your speed, your rate? Yeah, you have the formula. So 5 through 13, every other odd. So 5, skip 7, 9. All you're doing is substituting A and B, part A and part B. X is 0, does Y equal 2. Plug in X equals 12, does we get a 4? Okay, that's it. 2x minus y minus 3 gives you 0. So if you plug in 1 for x and 2 for y, 2 times 1 minus 2. So 2 minus 2 is 0. 0 minus 3, does that equal 11? But if I plug in 1 and negative 1, so 2 times 1 minus y is negative 1, and then minus 3 gives you 0. That's 2. Minus a negative 1 is plus 1, minus 3, 3 minus, yep, that equals 0. So this one, no, this one, yes. Okay, that's all you do. Yes.
I'm just gonna ask, is that all we're doing, just figuring out which one is the correct one?
Yeah, A or B. They both might work, maybe neither one of them works. Okay? It doesn't say. Well, it says determine whether each point lies on the graph of the equation. So it's just a yes or a no. A, yes, B, yes, A, no, B, no. A, yes, B, no, A, no, B, yes. Oh, you're skipping 11. I should have made you 11. All the way to 13. 13, you're just plugging in the x's and you're solving for the y's. And then they want you to write it as an ordered pair. Now, use a graphing utility to verify the graph. Use the resulting solution to sketch the graph of the equation. You know that's a linear equation, so you only need 2 points to sketch that line. And if you're going to use a graphing utility, you don't have to show that on your work. That's just for you to verify you got it right. Okay. But they're asking you to do a sketch, just plot it out. That's it. You need 2 points, you got it right. (17 to 22 all). Right. So 17 is a square root. So is number 19. 17 and 19 are both square roots. So the only two that have square roots, well, the only one that looks like an exact square root is this one. Look at the difference between 17 and 19. This is square root of an x. This is square root of an x squared. Now, we just got done. This is one of our parent functions, a square root of a simple x. That would be b. And we just got done demonstrating that when you solve for y, if you get number minus x squared over here, 16 minus x squared. This was the top half of the circle. That was the bottom half of the circle. So 9 minus x squared. top half of a circle. When you're at a loss, try plugging in a number. 0 is nice. 0 is the easiest number to ever plug in. 0 for x. 9 minus 0 squared is just 9 minus 0, square root 9. So when x is equal to 0, square root of 9 is a 3. So we get 0, 3. The only graph that intersects the y-axis at 3 is this one. And all I had to do was plug 0 in for x right here. And the only one that this one that goes through 0, 3 is this one. That's the answer. So this is B, and this one is C. 18 and 19 both have an x squared or a y squared. Now you know that x squared looks like a parabola. You know that if it's a positive x squared, it goes up. And if you have a negative x squared, it's supposed to go down. Now, so the only parabola that's opening down is this one. This one's going to the left. We'll talk about that in a second. But this one goes down. Again, let's check 0. 0 goes in. 4 minus 0 squared is just y would be 1, 2. There you go. Y equals a 4. And this is the only picture where you have 0 and a 4 for the y. What you can do is check a number. So what about this one? Well, if y equals x squared is a parabola, here you have x equal to a y squared. If the relationship from one to another, 1 squared, is parabolic, then it's going to be parabolic if it's the other way. So x equals a y squared is also parabolic, but here's the problem. It's not a function because it violates the vertical line test. Not a function, it's just an equation, relation. But when y is squared, the parabolas go sideways. When you interchange and switch your variables, so instead of squaring the x, we're squaring the y, things go left and right because now we're solving for x in terms of y. So when y equals 0, 5 minus 0 squared, x would have to be 1, 2, 3, 4, 5. X would have to be 5 when this y is a 0. So it goes right here. Okay. And there's no other graph where you have x equal to a 5. But sideways parabolas is when the y is squared instead of the x. So that takes care of 17, 19, 18, and 22. So left is 20 and 21. Now, absolute value. Absolute value is V-shaped. And absolute value is a V-shape. Only one of these is V-shaped. Okay? Absolute value 0 is 0, and then you take away 3. 0 minus 3 would be negative 3. Versus this is the other possibility. When you plug in 0, you get 0. 0 squared minus 3 times 0, 0 minus 0, that's 0. That's this one. And x cubed, 3 solutions. It's going to possibly cross the x-axis 3 times. 1, 2, 3 times. This is the only one that's possible of being an x cubed. Okay. Yes, sir.
So for those questions in particular, when you say you want to see like any work for it, how would you want us to go about doing it? Because you know,
There it's you're basically familiar with how the shifts happen. Then you're going to be a little bit ahead. If you're not familiar, then you can plug in a couple of numbers to get the shapes that we talked about and make it work until you are familiar. Section 1 does not get into the specifics of making everything, you know, how all the transformations are evident with variables and equations. It's just a matter of they want you to sketch. They want you to actually plot a whole bunch of points. I don't want you to plot a whole bunch of points if it's not necessary. So 2 minus x squared. Because it's x squared, you know it's a parabola. So you know it's going to be a parabola. Because it's a negative x squared, if the negative is in front, the parabola is going to open down. So you know it's a parabola that goes down instead of up. And then what you may want to do is let's plug in some numbers and see where this thing is. If you know where it's at, then that's fine. If you know how to use y equals a x minus h squared plus k, then you know exactly where the vertex is. You know exactly what a does. You know exactly what k is doing. You know all the pieces of the puzzle, and you can grab it, go straight forward. If you don't, 0 goes in. 0 squared is 0. 2 minus 0 is 2. Plug in the 1 to the right. Plug in 1. 2 minus 1 squared. 1 squared is 1. 2 minus 1 is 1. So when 1 goes in, 1 comes out. When you plug in negative 1, if I let x equal negative 1, y equals 2 minus parentheses negative 1 squared. So y equals 2 minus, that's now a positive 1. We get 1 again. It's right here. Remember, parabolas have symmetry from left to right of the vertex. So when negative 1 goes in, 1 comes out. And that's perfectly enough to draw the smooth curve of the parabola through those points. I typically want to see if it's a curve, I want to see at least 3, maybe 5, just to give some stability as to the nature of the curve, where it's at, and how much is it opening, and at what rate is it open. So that'll be fun. We know a square root is going to have this shape, x minus 3. So if you're familiar, actually, we'll do it 27. The math guy dancing, we know square roots look like this. If it's a positive out in front. So anytime you're graphing y equals absolute value of x, it's going to be a V shape. Now, if you're familiar with y equals the absolute value, or 3 times the absolute value of x minus h, and then plus k. A determines if it opens up or down, or how wide or narrow it is. H will slide it left and right. K moves it up and down. It has a -2 in it. So that means that the H is a positive 2. So this absolute value that is usually here at the origin 0, 0 has been moved over to positive 2. And now it's here. Then plug in another couple of numbers. Plug in 3. 3 minus 2 is 1. The absolute value of 1 is 1. So 3 goes in, 1 comes out. If you plug in 1, 1 minus 2 is -1. The absolute value of -1 is 1. You get straight line there, straight line there. For the absolute value. But inside, it's messing with your x's, and if you mess with the x's, it's a horizontal transformation. That's right. When you see a negative, it's moving it this way, to the right. Okay. That's gonna be for, and that usually is something difficult to pick up on for some people. I see -3, how come it's not going this way? Well, what -3 makes 0? 3, +3. That's why it's been moved over here. Okay. Oh, I'm doing the wrong one. Here. Okay, so look at this one. Huh? What -2 makes 0? 2 minus +2. So that's what should be that way to +2. If you saw x plus 2, what +2 makes 0? -2. It goes this way. When you see plus, the h is a negative. When you see minus, the h is a positive. You gotta do the opposite side. Yeah. See, when you see it, that's always a built-in negative. So you pull out the h, you take the opposite side. But k has a plus in front of it. So the vertical shift, if there's a plus, you keep the sign, keep for k. That's 29. I don't have all of them. I'm just kind of giving you an idea of what I expect. So if we look at the other ones, 31 through 43, again, every other odd, so that's 27, so that'll be 33 next. How do you punch up absolute value x plus 2 minus 2? Okay, so using the calculator. And do that. I didn't have these on my abacus when I was. My graphing slide. So, equations. Okay, so y equals the absolute value is going to be right here under math. Okay, so under math, you slide over 1 to number, and you enter. And right there is ABS, absolute value. So I click there, and it's going to take the absolute value. Now I'm going to punch in x plus 2, x. And you got to close the parentheses. So x plus 2, and then a minus 3. And we hit enter. And then I go to my graphic. And as you can see, the vertex of my graph is over here at -2 is the x, and the y coordinate 1, 2, 3 is at -3. Inside the equation, we don't have -2 messing with the x right here. It's x plus 2. But the bare bones equation, a times x minus h, and then plus k. So in front, a is a positive 1. If it's positive, that means your absolute value is going up. Plus 2, the only way to get plus 2 is because it's absolute value of x, it's a built-in negative. So it would have to be x minus, this would have to be a -2. So h right here is actually minus what? It would be minus a -2. So when you see this, you can just say, all right, h is a -2. I see plus 2, h is negative. The horizontal shift is a -2. plus k. So to get -3, you would have to be plus -3. So k, just by looking up here, is a -3. Ordered pair, this h, k together, alphabetically, h before k, -2, -3 is the vertex, the corner of that absolute value range. That's just the one point. I would need to see at least for these kinds of graphs. I would want to see 3. What's nice with the absolute value is it's straight lines. So that first point is established right here. Now let's just pick something, and you want to go, when you're going to pick a number to plug in to the right or the left of your vertex, your main number, go to the right. If you don't want to mess with negative numbers, I mean, you can. But if you don't want to, if negatives make you a little, queasy, pick a number to the right, stay to the right. That'll give you nicer numbers than picking a number to the left. So if you plug it into x plus 2, and you say, all right, let's plug -4 in. Well, look what happens if you plug in -4. -4, you got to keep track of extra negatives if you go to the left. And that'll happen no matter what. If you go to the right, I'm just going to pick 0. 0 plus 2 is 2. Absolute value 2 is 2. 2 minus 3 is -1. And you can see right here, it's going through 0, -1. Now, you don't even have to plug in anything if you're doing this by hand. Don't plug in anything on the left-hand side. It's got symmetry. In other words, this is -2. So when you go 2 to the right, the y value is -1. So that means if you go 2 to the left, because of the symmetry, when I go 2 to the left, this would be -4, but the y value has to also be -1. It's got to have symmetry to the other side. You don't have to plug in the -4 and actually generate it. You can just use left and right to help you figure it out. Okay? Perfectly fine with you guys showing that. So that is how you do these every other hour. Now you can see they start to get a little messy. Okay, and when you get to the other one down here, it's not even solved for. You got to solve for the y. In order to plug it into the graph encounter, you got to solve for the y. Okay. Just so you know, you did 33, then you're going to do 37, you got to do 39. The cube root on the calculator. Some have them, some don't. And you can go looking for it if you want to. Right here, it's got x squared and then your square root. You can go looking under math for it, and you can see it right there, option number 4. Cube root, and then what's in the parentheses. And then 5 would be 5th root, so you need to do a higher root. But you can also type in, if you remember your stuff, 39, you could also type this in, just parentheses, x minus 8, a cube root, you can just raise that to a 1/3 power and it would accomplish the same thing. So you would type it in, and you would want to make sure you use parentheses when you do the 1/3. Parentheses, x minus 8. Those are parentheses, and then the exponent key is this one right here, the little hat, right above the division. To the, now, if I don't put parentheses, if I just go to the 1/3, 1 divided by 3. What it's doing is it's raising all of that to the first. And then it's dividing the whole thing by 3. Okay? That's why parentheses are important. You got to put this in parentheses, so it will make sure it's raising it to the 1/3. Wrong thing. Do that. 1 over 3. And close the parentheses. You see how there's a -8 in there with the x? So it's the same rule about x minus h's. We're messing with the x coordinate 8 times, 8 units. And because you see minus, it's going to shove everything to the right 8 units. The graph of y equals simple cube root x looks like this. That's a simple graph, not so much fun like that. And so what -8 is doing is it's taking this point and it's sliding it over to here and putting it there. Okay, horizontal shift. Look at 0. 0 minus 8 is -8. The cube root of -8 should equal, right here is -2. When you plug in 0. So my window will be 0. Now, I want at the, you're going to go back and do 45 after you do, all the way to 55 every other odd, and then you go back and do 45, and then 61, 63. But since I'm here anyway, let's look at 45 right now. I just want you, just like they're saying, describe the viewing window. They're not putting units on the viewing window like they've been doing on all the other problems. So over here, the A through F, you got, you got max and mins. So on 45. Yeah, the equation, the viewing window, you're supposed to, describe the viewing window. In other words, what's the x minimum, what's the x maximum, from what to what is it going, and then on the y-axis, from what to what is it going. So if we just think for a second, the easiest number to figure out, that's a linear equation, would be the y-intercept. If you plug 0 in for x, -10 times 0 would be 0. What does y equal? This right here would have to be 50. And if that's 50, and this is sliced up into 4 parts, then each of those single parts are what? 25. So 25, 50, 75. This up here is a positive 100. Now down here, it doesn't go all the way down 4 times. It only goes down 2 times. So on the y-axis, it goes from -50 to 100. And you know what you could do is you could then figure out what's going on with the x's. If you let y equal 0, -10x plus 50, add 10x, and find the x-intercept, 10x equals 50, divided by 10, the x-intercept is 5. So this right here is a 5. And it looks to me like it's right in the middle. From here to here. You have 2 notches to the left of it. Well, you got 3, you got 2 and then the endpoint. So you got 2 notches and an endpoint, you got 2 notches and 0. So it is exactly in the middle. So this must be a positive 10, and this over here would be a negative 10. That's all you're doing. Okay? Now, 47, you don't have to actually solve it. It says, explain how you would use it. Well, if you're trying to solve, how would you use a graphing utility to verify that y sub 1 is equal to y sub 2? Identify the rule of algorithm. Oh. Distribute 1/4. If you distribute 1/4 on y sub 1, you get 1/4 of x squared, and then minus 1/4 of a is negative. Distribution is the rule. If you want. Okay, I'm going to rewrite these directions for you a little bit. Can I go? Use the graph utility to graph the equation. Use the trace feature of a graphing utility to approximate the unknown coordinate of each solution point, accurate to 2 decimal places. Hint, you may need to use the zoom feature of the graphing utility to obtain required accuracy. Yeah, no. Well, maybe for part B. Maybe for part B. But for part A, it's a lot simpler. Right? I know you can just plug it in and use your calculator and get the answer, but they want you to get used to the technology. So on 51, y equals square root 5 minus x. I'm going to show you one way with part A. 3 comma y, but I do have to use the trace for part B, x comma 3. So when x gets close to 3, so when they're talking about the zoom, the trace is right here, right above the option arrows. And if you click on trace, you're going to get that little cursor up there, and you move it left and right here. And how do you know when x equals 3? Well, it's telling you exactly where you are as an ordered pair right here. I'm at 1.9 for x. The y value is 1.76068117. But if you know exactly what x is, then you're going to do this. The second button, and then you hit calc. Second and calc. And what we want it to do is to calculate a value. I want the calculator to tell me the Y value if I input the X value. So it's the very first option. And all I got to do is say, all right, when X equals 3, and then I hit enter. And when X equals 3, the Y value is 1.4142136. So it gives me the exact value, and I won't have to use the trace, feature to do it. Because sometimes when you're in the trace feature, if your window is not set up nicely, you will never be able to get that little cursor to land exactly on the 3. All you can do, and this is a good rule of calculus, all you can do is get really close to the 3. And the direction said, you may have to zoom if you want a more accurate reading. So if you have to zoom in to get a better picture of what the Y values actually are. But that's how you can, if you know what the X's are, you can just use that. Now, when Y is a 3, then I'm going to have to use the trace, because when you do the value, it doesn't give you an option of plugging in something for Y. Because Y is the dependent variable. X is independent. It doesn't mind just plugging in an X value. It won't let you do the dependent one. So when on the trace, I'm watching the Y coordinates. And what I want to know is, when is this thing going to do when I get close to the 3? Right now I'm at 2.6267. Two 2.913, 2.94, 2.98. Okay, I made it. When Y is exactly 3, X has to equal a -4. And that's the only way you can do it if you're using Y to figure out X. Again, if it didn't come out nicely, I would have to use zoom to get a close-up picture so I can move in closer to where the Y is. Uh, 55. This is A, B, C, and D. You're plugging these values in for X, 1 for X, 3 for Y, and plug it in. Does it solve the problem? Does it make that left side equal 25? On part D, this guy right here, 0 goes in for X. 0 minus 1, you get -1 squared. And then you're plugging 2 plus 2 square root 6 in for Y. 2 plus 2 square root 6 minus 2 squared. Does that equal 25? That's all you're doing. It's A, B, C. And then a word problem. So you decide 61 or 63. What you want to see. 61 is modeling data, hospital purchases, or 63 modeling data, single family houses. Which one you want? Well, all right. Since I just finished 15 season of ER, I'm going to do 61. I didn't hear anybody say 63. It doesn't do me any good because I blew my ears out back when I was in my 20s listening to my radio about it. It actually happened, the curse of the parents. Don't blow your ears out. Okay, yeah, right now. Okay, let's just do this. But parents always right. Me and my Pink Floyd. Yes. All that damn rock wrong. So hospital purchases a new magnetic resonance imaging MRI machine for $500,000. Now, that's the thing about some of the things on ER. They put somebody on a gurney from paramedics they have a gurney. They take her up to the MRI machine. They didn't switch out the gurney. They turn the MRI machine. You know what MRI is? Magnetic resonance imaging machine. The paramedics machine is made out of metal. A gurney is made out of metal. The woman was flattened into the gurney onto the MRI machine. It was hilarious. Smell it, so yeah, I know she was all right. It was a stunt person. Probably wasn't even a real person. Think about how much the Lord had to sue for. Did your high school teacher tell better jokes? Yes. Better jokes? Huh? What?
He was afraid.
I used to. I think I lost my sense of humor when I lost my hair. No, I don't know what that. Nobody's in the last few years. No, I couldn't tell.
No, you just have that audience.
I'll take that. Okay. The depreciated value. What does that mean? When it depreciates. Is it just feels bad? No, it's underappreciated. What depreciates? What does it mean? When your car depreciates after you drive it off the lot, it lowers because it's not a brand new car anymore. It's been used, or they use this pre-owned. Okay. Depreciated value, reduced value. Y after t years is. So there's a linear equation because y to the first, t to the first for 9 years. From 0 to 9 years, t represents years. So y is equal to 500,000 minus 47,000 times t for a domain, because they're telling us what t is, and t is of x instead of a, t is the x, there's no x in here, so t is our x. Use the constraints of the model and the graphing utility to graph the equation using appropriate viewing window. Now, here's the biggest problem when I see a student do this problem for the first time. They press the t, and it won't graph for them. So they'll try to go y sub 1 is equal to 500,000 minus 47,000, and they'll press that t. So figure this out. Minus 47. And then t, again, you can't see the t. And every time you hit that, it's not going to give you t, it's going to give you x. So how do you get the t? Well, in green, all over the numbers, right here, right above the 4, alpha means alphabet. That's how you can activate that t. So they'll press alpha, then t. So if I go alpha t, now it's got 47,000, and there's a t in there instead of a x. And now when I want to tell it to graph, let's see, I'm in the window. Now, the window, t is from 0 years to 9 years. So my x minimum should be 0. My x maximum should be 9. At 0 years, how much is this MRI machine brand new? $500,000, brand new. So the y minimum is going to be 5, or actually my Y minimum, it's never going to be less than 0, is it? My Y minimum could be a 0, and then my Y maximum on the very first year, when I first get it, it's going to be worth $500,000. Now, you're going to see all of this is a little bit crazy. So I can graph it. And what the heck is that thing? A box? Yeah, that's technically what this graph. Because it doesn't know how to handle the T. Look at all of these answers that we got. Right here is a table. For all these values, the answer is 500,000. It's not doing the minus 47,000 T. It's not doing that part. It's just graphing 500,000 like it's a horizontal line up here, 500,000. Because your calculator is always, when you're in function mode, at the very beginning, an x-axis and a y-axis. So instead of typing this in, make it an x. That's how it is. And you can see in the table, x. The only time you would use t's is if your calculator, if I go to load right here, if you're in parametric mode. If I switch this thing over to parametric, look at the equations. Look at I have to type in 2 equations. X sub 1, the first equation with respect to time, then the equation for y with respect to time. So there's my first equation, x and y with respect to time, then a second equation, x sub 2 with respect to time, y sub 2 with respect to time. But that's when you use the t. So you always got to make sure you're in the right mode if things aren't working. And just to give you an idea, if I go to polar and I pull up equations, now it's R, because it's graphing the length of a radius dependent upon the angle theta. Okay, so when I click on the X, it's going to give you a theta instead of a X. Okay. Back to function. Down. There. And the graph. That's a lot better. Linear. Now look how thick this is over here. That's my y-axis. The reason why it's so thick is because when you go to window, I didn't change something. On my y-axis, it's from 0 to 500,000. The y scale. The y scale is where I put these little notches. So on the x-axis, I put 0 to 9, and my x scale says put a little notch every 1 unit. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I get an idea of the scale. But look at where it's putting a notch on the y-axis. From 0 to 500,000, it's putting 500,000 little notches along the y-axis. That's why they're so close together, it looks like a solid line. So if I change that y scale to 100,000, and then do my graph, then you can see 100,000, 200,000, 300,000, 400,000. That's that. Okay, so part A was using a traceable model and graphing utility to graph the equation using appropriate view and window. Use the value feature, and I showed you how to do this, of the graphing utility to determine the value of y when t is 5.8. So right here, under calc, where it says trace, you hit second, and you hit calc, and I hit enter on value, and we just want to plug in x equals 5.8 years. And at 5.8 years, The MRI machine is worth $227,400. That's all you're doing. And then last but not least, use the zoom and trace to determine what does T equal if Y is 156,900. So if the Y value is 156,900. So now we're going to trace. So 156, right there, I'm at 225, so I got to go to the right. It's got to be worth less. 171, 167, 1. So you see right here, it skips over. I'm at 153, and I go to the right, the left, 158. So it's somewhere between 7.276 years and a little bit to the left, 7.18 years. So now we zoom. So you hit zoom, and all you got to do is hit zoom in. It's going to zoom in where your cursor is. So I'm going down one. I'll zoom in where my cursor is. And so 7.1, I want 116, 156. I'm going to go to the right now. Oh no, I'm bad. I got to show it where I want. 156. So I'm going to put the Y value at 156. Right there, 153, 161. I'm going to higher, and then I hit enter. There we go. And then it's going to redraw it, and then I'll do trace of it until I can get that 160, 56,900. Oops. 156,875. I think I have to zoom one more time. All right, so you would zoom one more time, and then get that one out. Get the X one. All right, take and roll. So that's 1.1, and we'll do 1, 2, and 1, 3 on Thursday. Josh Aguilera. Here. Jasmine. Here. Eduardo. Charles. Francisco. Here. Lewis. Here. Ryan. Marcelino. David. Daniela. Alyssa Rios. Alma. Brian Sainz. Kelsey. Anyone you have to call? You guys have a great couple of days. We'll see you on Thursday. I had them right before class from 11 to 11:50 or to 12. Basically, I'm hanging out before class, so if you want to come anytime before class, you come.
Yeah, that's actually what I was gonna do. Like before or after class on like these days.
Just before,
Yeah.
but I also have Monday through Thursday
Yeah.
at 7:30. It's early.
Well, I work every day that I'm not in class. So.
Gotcha. Okay.
But I just had a question. So everyone looked at me strange when I when I said that I was taking this class, and I didn't take a class that you taught before.
So where are you coming from? Where were you before here?
Like math stories. And then I've been going to college. I've been taking, like, I took statistics, and now I'm in this class.
So
And I'm just worried that I'm like behind.
no.
But I don't feel.
Have you, so you've done that, you've done algebra 2.
Yes.
That's all you do.
Cause like I understand for the most part,